All right, we are going to start today's lesson with factoring. Now, you've done factoring in the past, and the first place we always start with is looking for a greatest common factor. Another thing we're going to be looking for are special factoring situations, and the one we'll be looking for the most is the difference of perfect squares. And this is where I have a number squared minus a number squared, and that will become a plus b times a minus b. Basically the square root plus and the square root minus every time. If we look at an example, the square root of w is w, the square root of 49 is 7, so I have w plus 7 and w minus 7. We will come back to why that is later, but trust me that that is a very useful pattern if you learn to recognize it. Another pattern that's useful but not necessary to recognize for factoring is a squared plus or minus 2ab plus b squared will always factor into a quantity squared with the plus or minus. So when we look at z squared plus 6z plus 9, it fits our pattern because my a is my z. If I look to break 6z up so it matches my pattern, if I take a 2 out of 6, the z is my a, that means the 3 is my b. And if I look at 9, b squared, it is 3 squared. So by the pattern, this is plus, so that's what dictates this being plus. I'm going to have z plus 3, the quantity squared. I use this more in place of foiling and working a problem this way than I use it for factoring. But if you like to recognize number patterns, it's a useful thing for number patterns. Two other techniques that we are going to talk about is we're going to talk about grouping for fourth degree 4 terms, and we're going to talk about trial and error for trinomials. Now let's look at some greatest common factor problems to start with. Now it's very easy to see that 8, 32, and 4 all have a common factor of 4. But what might be newer to you is that 6 n's to the 6th, n to the 3rd, and n to the 2nd all have a common factor of n squared. So in the same way, remember when we take these out, greatest common factoring is the opposite operation of the distributive property. So when we do the distributive property, we're multiplying. So to undo it, we have to remember we're dividing. So 8 divided by 4 is 2. N to the 6th divided by n squared is n to the 4th. And remember, when we divide exponents, we subtract. When we're dividing those bases, we subtract their exponents. 32 divided by 4 is 8. N cubed divided by n squared leaves n. 4 divided by 4 leaves 1. N squared divided by n squared leaves 1. And that is fully factored because there's no way to factor 2n to the 4th plus 8n plus 1. Trust me. If we look at this next example and we start looking at the common factors there, 70, 50, and 70 have a common factor of 10. When I start looking at the variables, m to the 3rd, m to the 6th, m to the 4th, m to the 3rd is the common factor. And when I look at n to the 7th, n to the 4th, and to n is a common factor. So when I divide these out, 70 divided by 10 is 7. M to the 3rd divided by m to the 3rd is 1. N to the 7th divided by n is n to the 6th. Minus 50 divided by 10 is 5. M to the 6th divided by m to the 3rd is m to the 3rd. N to the 4th divided by n is n to the 3rd. Plus 70 divided by 10 is 7. m to the fourth divided by m to the third is m, and n divided by n is 1. If you want to check your problem and you do the distributive property, you will get right back to where you started. To check it, do the distributive property. Because remember, we don't want to change the numerical value of our problem, we just want to change the way it looks. That is completely factored. Now in this one, 45 and 80, I know it has a common factor of 5, whether that's the biggest or not, it doesn't matter. I can always take another factor out. So I'm going to take out 5, and that's going to leave 9k squared minus 16. 80 divided by 5 is 16. Now this is the difference of perfect squares. 9 is a perfect square, k squared is a perfect square, and 16 is a perfect square. So that will factor into 3k minus 4 times 3k plus 4, where you take the square root of each of those perfect squares. That is fully factored. Now the next example also has perfect squares and or a common factor. Take the 3 out, and I'm left with x squared plus 16, which both are perfect squares, but you cannot factor addition of perfect squares. So this is actually completely factored. Now, let's talk about this whole factoring trinomial thing. Foiling and factoring are opposite operations. They undo each other. So when we meet a trinomial, which has 3 terms, such as p squared plus p plus negative 20, we want to take it apart and find out what 2 numbers built it, what 2 ingredients went into it. So let's go over here and FOIL. So first 2 terms times each other. P times P is P squared. Outside, P times negative 4 is negative 4P. Inside is 5P. Outside is negative 20. Now what's important about reminding ourselves about FOIL is the outside and the inside terms, because they always end up combining. They end up adding. And so we get p squared plus p minus 20 as our final number. But that outside and that inside term, which become p, is our important term because that dictates our factoring. That's where we start when we're factoring, is that middle term. The fact that it's built by multiplying one term from the p times one term of the constant, one term of the p, and the other term of the constant, multiply those together and then add them, is crucial to us understanding how to factor. Now this factoring table here is one you've probably seen before. This is how we know what factors plus, minus, minus, plus. I would encourage you to think about how numbers are built when you look at this. And if you see this as your trinomial, so there's little terms in each of these spots, okay, in my factors, if I multiply the last 2 numbers together here, a positive number times a positive number, it has to be positive. If I multiply a negative number times a negative number, it has to be positive. That is why those back numbers help us know what our factors should look like. I just got done saying you always add outside and inside, and if I add 2 positive numbers, that outside plus inside is going to be positive. In this case, outside and inside are both negative. When I add 2 negative numbers, I get a negative number. Now these 2 factors seem to be the same, but in fact they produce 2 different results. If I take a positive times a negative, think about my last terms, I get a negative. positive times a negative, I get a negative. But when I look at that outside and inside business, and that outside and inside business, I have a positive and a negative number. If my positive number is bigger when I add it with a negative, I get a positive. If my negative number is bigger when I add it, I still have a negative. So you don't really need to memorize the chart. You just need to know how numbers are built. So let's review our basic factoring. If I'm looking at something like p squared plus p minus 20, first thing we do is put two sets of brackets, put a p on each one. This we usually think about as a minus. If I have a plus minus, that means I have to have one of each. And now I'm going to start through trial and error looking for the two factors of 20, 1 and 20, 2 and 10, 4 and 5, that are going to basically subtract to make 1. Because remember, p comes from those two being multiplied and those two being multiplied and then being added together. So we would go through trial and error. We would put 1 and 20 in here. 1p minus 20p is minus 19p. That's not going to work, and we would erase. And then we would put 2 and 10, and we would have 2p minus 10p is going to be minus 8p. And that doesn't work, and we would erase. And then we would put 4 and 5, and when we check that, we have 4p minus 5p. We have minus 1, so we're very close. And when you have the right number and the wrong sign, all you have to do is go in and change the signs. And so this, in fact, becomes p minus 4 times p plus 5. And that was our starting problem. Now let's look at this guy that's trying to hide here under all my writing. And let's practice factoring him. So we have our two sets of factors. Put a t in each one. Minus plus is minus minus. We look at the factors of 21, which is 1 and 21, 3 and 7, and we think to ourselves, which of those two factors would go here and here, that when combined under addition are going to make 10. Well, it's clear that 3 and 7, check my inside terms, 3t and 7t make negative 10t. Quick check your first terms, t times t is t squared. 3 times negative 3 times negative 7, positive 21. This one factors into t minus 3, t minus 7. We will go